Japan unveils EC-2 electronic warfare aircraft to blind enemy radar and protect fighter jets. Japan has revealed the EC-2 electronic warfare aircraft developed from the Kawasaki C-2 airlifter to conduct standoff radar and communications jamming missions. The Japanese Air Force released the first official images of the EC-2 electronic warfare aircraft derived from the Kawasaki C-2 transport. The aircraft is designed to jam radar and communications while operating at a standoff distance. The program plans 4 EC-2 standoff jammer aircraft to replace the single Kawasaki EC-1 electronic warfare aircraft introduced in 1986. On March 12, 2026, the Japan Air Self-Defense Force Air Development and Test Command released the first official pictures of the future EC-2 electronic warfare aircraft, a standoff jammer derived from the Kawasaki C-2 military transport aircraft. The EC-2 is intended to replace the EC-1, an electronic warfare aircraft introduced in June 1986, and of which a single unit is operated by the Japanese Air Force. The EC-2 forms part of a modernization program aimed at expanding Japan's ability to conduct electronic attack and electromagnetic intelligence operations at extended distances from adversary air defenses. The program includes the procurement of 4 C-2 standoff jammer aircraft, representing a 4-fold capability increase. The EC-2 is designed to interfere with radar systems, communication networks, and other electronic sensors while operating beyond the engagement range of hostile systems. The aircraft is also intended to support counter-air operations and other tactical missions requiring suppression or disruption of adversary electronic capabilities. This capability reflects a broader Japanese effort to strengthen its control of the electromagnetic spectrum within joint operations involving air, maritime, and land forces. The EC-2 program, previously known as C-2SOJ, began during fiscal year 2020 and is structured by the Japanese Ministry of Defense in 2 main phases extending over more than a decade. The first phase, running from 2020 to 2026, focuses on establishing a standoff jamming capability against data links and integrating multiple electronic warfare subsystems into a unified airborne architecture. A second phase, running from 2023 to 2032, concentrates on refining the systems, improving operational reliability, and preparing the EC-2 for full operational deployment. The aircraft incorporates technology derived from earlier Japanese electronic warfare equipment, including the J/ALQ-5 electronic countermeasure device and advanced radio wave measurement systems designed for electronic intelligence and signal analysis. The development effort relies heavily on domestic technologies to maintain operational independence and limit disclosure of sensitive capabilities. The EC-2, therefore, represents a transition from a single experimental electronic warfare aircraft to a small operational fleet capable of supporting sustained missions. Externally, the EC-2 differs significantly from the standard C-2 transport aircraft due to the installation of large radomes and antenna housings required for electronic warfare equipment. The C-2SOJ features a large bulbous radome on the forward fuselage, comparable in concept to the prominent nose structure installed on the EC-1 aircraft. Additional bulges are visible on the top of the fuselage and along the sides of the aircraft between the wings and the horizontal stabilizers, indicating the presence of electronic surveillance and jamming systems. These structures likely house antenna arrays used for detecting radar emissions, analyzing radio frequency activity, and transmitting jamming signals. The modifications confirm that the C-2 standoff jammer aircraft is configured primarily for electronic attack and signals intelligence, and the unit observed seems to be C-2 airframe number 18-1203, which has undergone extensive structural modifications for this mission. The EC-2 replaces the EC-1 electronic warfare aircraft, which is derived from the earlier Kawasaki C-1 tactical transport aircraft introduced during the early 1970s. The EC-1 was developed in 1983 and underwent flight testing beginning in December 1984 before entering operational service in June 1986. The aircraft was modified with a distinctive black bulbous nose, tail radome, and multiple antenna fairings integrated along the fuselage to support radar and communications jamming systems. Its equipment included the J/ALQ-5 electronic countermeasure system, later upgraded to the J/ALQ-5 Kai standard, along with Toshiba electronic intelligence systems and additional avionics originating from American electronic warfare equipment. The aircraft has been based at Aroma Air Base in Saitama Prefecture, approximately 55 kilometers northwest of Tokyo. From this location, the aircraft has supported electronic warfare training, testing activities, and operational evaluation missions for the Japan Air Self-Defense Force. The EC-2 is based on the Kawasaki C-2 military transport aircraft, a domestically developed airlifter designed to replace the older C-1 and complement the C-130H Hercules within the Japanese airlift fleet. The C-2 measures 43.9 meters in length, has a wingspan of 44.4 meters, and stands 14.2 meters high. Powered by two CF6-80 EC-2 turbofan engines, the aircraft can reach speeds of Mach 0.82 and carry cargo loads of up to 20 tons across distances of about 7,600 kilometers. The aircraft's maximum payload capacity reaches 36 tons, allowing the transport of heavy assets such as MIM-104 Patriot missile systems or H-60 helicopters. The airframe incorporates a glass cockpit, fly-by-wire control system, and a tactical flight management system intended to improve operational efficiency and reduce pilot workload. Since entering service in 2016, the aircraft has been used for domestic missions, including logistics operations and disaster relief support. The airframe was also designed with sufficient internal volume and structural capacity to support specialized mission variants. In addition to the EC-2 electronic warfare aircraft, the C-2 airframe has already been adapted for the RC-2 electronic intelligence variant designed for signals intelligence collection. The RC-2 conducted its first flight in 2018 and includes smaller fuselage bulges housing electronic surveillance equipment used to intercept and analyze radio frequency emissions. Testing of the C-2 airframe also demonstrated the ability to conduct semi-prepared takeoffs and landings on unpaved surfaces, increasing operational flexibility during emergency operations or deployments to austere airfields. Development of the C-2 began during the early 2000s under the internal designation CX, and several structural components were shared with the Kawasaki P-1 maritime patrol aircraft to reduce development costs. This shared design approach allowed both aircraft programs to benefit from common manufacturing processes and systems integration. The EC-2 electronic warfare aircraft also forms part of a broader effort to expand the operational roles of the C-2 beyond transport missions. Japanese defense planning has considered arming the aircraft with long-range strike weapons, including a modified Type 12 surface-to-ship missile and the AGM-158 Joint Air-to-Surface Standoff Missile. Integration of such weapons could extend the aircraft's operational reach to more than 11,000 kilometers, depending on mission configuration. These potential capabilities would support counterstrike missions outlined in Japan's defense buildup program and broader national defense planning. Combined with electronic warfare variants such as the EC-2 and signals intelligence aircraft such as the RC-2, the C-2 airframe is evolving into a multi-role aircraft supporting transport, intelligence gathering, electronic attack, and long-range strike support functions. The EC-2, therefore, represents a significant component of Japan's effort to modernize its airborne electronic warfare capabilities and strengthen operational readiness within the electromagnetic domain.